So this is podcast one on my new podcast about Prolog and also the software I will be creating with it. A startup that I'm hoping will lead to success for me. And this will be on YouTube with little clips, on Instagram as well. So what Prolog is a fascinating language. It's from the early 70s. It was invented in France to do, work on natural language processing. Right now, natural language processing is, the modern day AI, like LLMs, large language models. That's natural language processing. That's a subfield of AI. Now, Prolog from the 70s was the original AI boom, which is known as good old fashioned artificial intelligence. Is based around, logic and like knowledge representation, basically hard coded knowledge by humans. Whereas the modern day is like machine learning, which is basically statistical AI, right? So you just have lots of examples, and the computer will learn to predict from those, what's known as statistical estimation, right? So it's basically statistics. Uh, now, so why am I talking about Prolog then? It's also a programming language, and it's also a very advanced programming language. So a few things. Let's say it has garbage collection built in. So a language like C doesn't, but many languages have garbage collection nowadays, like uh, Java and Python and JavaScript and all these languages, C sharp. But in the 70s, a lot of languages didn't, like assembly and C and I think Fortran, I'm not sure. They didn't have garbage collection. Even C++ doesn't have garbage collection, like natively. So Prolog was kind of advanced in that way, although there were other garbage collecting languages back then as well, like Lisp in the 70s. Okay, so another thing is it distinguishes itself is that the language is built around the concept of backtracking search, right? So it's like you specify a goal to reach, like basically a template of this is the result I want. Is it true or not? Right? And instead of true or not, you can also like leave a gaps in it, and it will fill those gaps based on whether something is true or not. So it searches through, whatever you give it. You'll give it a set of facts and a set of rules, and it will connect all that up and then tell you whether what you asked is true or not, or what thing makes that thing true. So it can give you a result, right? Whereas in other languages, you sit down and tell the computer how to do something, right? In Prolog, you don't tell how to, you just say what is. Okay, so it's very different that way. Now it belongs to now it belongs to a type of thing called constraint programming, and actually you can also think of it as operations research type algorithms. So it's like linear programming that you might see in the rest of engineering and maths. It's like you specify a set of constraints and it finds the result. Right? You can almost think of it as an optimization problem, but Prolog doesn't do optimization, it does constraint satisfaction. Okay, whereas a lot of like a linear programming or mathematical programming, as it's known, it's constraint satisfaction, but also optimization, finding the best result. Okay, so now if you think about it, like constraint programming or constraint satisfaction optimization are kind of silver bullets, right? What they do is it's like you don't specify an algorithm. You say these are the set of constraints, this is what exists, what's the answer? Right, now that's how I described Prolog a bit earlier as well, is you don't say how to, you say what is. Okay, and one way to also think of it is ontologies. So in philosophy, it's like ontologies are like the set of concepts that exist. So you could see Prolog as, how you program in Prolog is you specify what set of concepts exist in the world, and then how they relate to each other. Now also Prolog is very similar to relational databases, like the things that SQL, like MySQL, Oracle, Postgres, where it's known as relational programming, right? So in those also you kind of think of it as specifying constraints. You're like, these tables are entities and they exist and they have relationships between each other. What's the answer? So Prolog does all of that kind of, but it has a bit extra over that. Okay, so like relational databases don't do recursion. Usually you need extra layer of procedural languages, whereas Prolog does recursion and everything built in. Okay, so one other way to think of it is kind of a combinatorial programming, right? So in Prolog you have things, entities, you have like you combine those things, so you get more and more possible combinations of things, right? Like if you can put the numbers 1, 2, 3 in multiple ways, you can put 2, 1, 3, or you can put 3, 2, 1. So it's like different combinations you can have, right? So there's like a permutation. So you can also think of programming in Prolog as you specify the combinatrix of things, and then you filter to find what satisfies the criteria, and you get either one result or all the results that satisfy the criteria. Okay, so now I find that kind of thinking amazing, because in a lot of computer science, you might need to know an algorithm of how to solve something. But if you have these kinds of, Prolog, or like let's say relational databases, you don't specify an algorithm, right? So but it somehow does stuff. So that's why one reason things like relational databases, when they came out, people thought the field of programming would be dead, right? Like your secretary could just do the SQL programming, but relational database programming, but it didn't work out like that. Same with Prolog. People thought, well, this would put programmers out of business because people could just specify their program almost naturally and in Prolog, but that didn't work out either, right? Kind of like spreadsheets kind of did that. Spreadsheets made programming available to a lot of people, and people thought, relational databases and Prolog would be like that, but even more powerful. It didn't work out because people like the programming is really not about that, right? Like you still need someone to think clearly about the problem and that's the computer programmer or software developer. So even if you make higher and higher level languages, you'll still need someone to sit down and clearly think things through. Okay, so now of course these algorithms that, let's say you do stuff in Prolog and the algorithm is automatic, they won't be as efficient as custom designed algorithms. So for example, Prolog has parsing built in, and like taking source code of a computer language and turning it into something that can be, so you can do something with. Now usually all the languages don't use Prolog as their parser. They use a custom designed parser because it's more efficient. And so a lot of, in other things too, it's like it might not be the most efficient way to solve the problem, but it means you don't have to think of the algorithm. It's not 100% true because it kind of becomes like, well, it's another way to solve a problem, right? Like you can either solve a problem thinking about how you're gonna make a computer solve it, or you can solve a problem by saying, well, these are the conditions that exist, these are the constraints that exist, and then what's the solution, right? So in one sense it's not, and that can be considered an algorithm, let's say, right? So like, or not an algorithm, but it's like it might be just as hard, might take just as much time to specify the problem as a set of constraints as to write a procedural program or algorithm to go through and solve the problem, right? So it doesn't necessarily mean that you'll actually save time by describing it as constraints. Now, but often it might, right? So like so if you do Prolog, you'll see lots of like examples, and Prolog might do something in a few lines of code that in another language would take 100 lines of code. So and on like that. So there's many kinds of places where that exists. Now, yeah. So also I just find, so as a result of all that, programming in Prolog is often very elegant. It's often difficult as well because you have to think. You might have to, like, sometimes by using Prolog you can do things 100 times easier than another way, but sometimes just trying to get it to do something might be very hard because you're just so used to thinking procedurally or algorithmically that specifying it another way might be just so much harder that it's taking you longer to write in Prolog. Now, and that might be one reason why most people don't use Prolog, right? So a thing of Prolog is that you don't have for loops, right? Which is a good thing in relational databases as well, or constraint mathematical programming. You don't have for loops, right? So that's actually a good thing. In Prolog, you don't have if-else statements. Almost everything is an if-else statement, right? Like if you put different clauses, they just mean the different possible branches of a tree, the branches, like an if-else statement would do in other languages, right? And the way you get around for loops is there's either two ways. So one is, it's like by backtracking, the computer is automatically kind of looping through things, or you can have recursion, so you can have it go through and call, in other languages a function or procedure, but in Prolog they call clauses might call itself and then run itself again and run itself again and run itself again until, some kind of condition is reached for success or exit. Yes, so Prolog also has lists, and it's very interesting because it has the kind of lists you would see in a functional language like Lisp, right? It adopted it from that, but it's very powerful beyond the Lisp method because you can do pattern matching on the list structures as well. And but advanced Prolog programmers recommend to use lists in Prolog, right? They recommend not using side effects, which is, so in Prolog you can do things like assert and retract from the database. You can put things into the database and retract, like a SQL database, right? You just can have it so that it puts a fact in, takes a fact out. But advanced programmers of Prolog say, that's not the right way to do it. It will lead to inefficient code, but also even more, it will lead to bugs. Right, so you want to use lists in Prolog, but in the beginning, it often seems a bit harder to do it that way. Something, right? Like you just assert something into the database and pull it out again, but it's the wrong way to do things. So in future podcasts, I will go through more Prolog basics. Maybe I'll have a screen so I can write stuff and you could see what I'm talking about in terms of code. Maybe I'll have it structured, like this is a list of topics we'll discuss and go through them. There are not many Prolog podcasts on the internet. Like Marcus Triska, who wrote The Power of Prolog, he has one. It's very good. I watch it. He does have a thick German accent, and it requires and he goes through topics quite concisely, and for a beginning programmer or someone even new to Prolog, it might go over their head. So I'm thinking, I'm filling a niche, my enthusiasm from Prolog, and maybe I can fill that niche by having a dumbed down, much slower version of what he's doing, but also different. And I might, do comparisons of how you solve a problem being solved in Prolog and in another language. Maybe I'll do comparisons between Prolog, Haskell, Lisp, Java, JavaScript, Python, things like that. Now, and I might just do it by pulling examples from Rosetta code, right, where problems are solved by many different people in different languages, and you can see a direct comparison how you solve problems in different languages. Now, I also want to do a startup, create a piece of software that successful monetarily solves a problem. The problem I want to solve is, fundraising for projects through the political system, right? So, you want, let's say, kind of legalize corruption. Let's say you want to bridge to somewhere, right? Like the typical, bridge to nowhere problem or pork barrel problem, right? But it doesn't have to be. It could be like the reverse. Like it could be, getting rid of a project and saving money for the government. So the way it would work is like, how do you get the government to do things? You have to pay politicians to pass legislation, right? The lobbying system. So rich people or special interests will come in, pay lobbyists. Lobbyists will funnel that money or wherever, help politicians get elected, and for that, the politicians will pass the legislation for the special interest or the rich person, whatever. Now, this would be a system where it's like, let's say the masses or people can get through on the internet, form through the internet, and then directly pay politicians, right? Let's say we want to make schools only from 9 till 12 rather than 9 till 3, right? Like, let's cut the school day in half, right? So let's say kids could organize themselves, or teenagers, right, could organize themselves through this software. If, let's say, for a particular city, let's say New York City, right, if 100,000 kids get together on the internet and give like $10 each, that's worth 100,000 times 10, that's worth $1 million, right? And maybe that $1 million might go to the mayor of New York and he might pass the legislation. Or maybe you need to give 100,000 each to 10 council members of the New York City Council, and so they would be willing to pass that legislation for 100,000 each, or something like that. Or 100,000 goes to advertising for them for their next campaign, something like that, right? So the system for doing all that through the internet, the softwares that allows people to come together, decide what a project is, people to pay money towards a project, people to decide which politicians should be receiving money so that they will pass the legislation, maybe a communication channel through there for the politicians and the people donating money for a special cause, a special project, and all of that, right? And how would you coordinate all of that without having a person coordinating, right? Like there isn't a lobbyist in the middle somewhere. It's like, how can people self-organize through a website and all that gets done, right? So that's they might, right, like even the politicians, like maybe people will suggest politicians that should get funded, and how do you decide like which politicians should get the money or how much of it? So that's a coordination problem. And maybe there's some voting mechanisms or things in the software, or whoever donates more gets more say on which politician gets funded. Maybe politicians like come and say they don't want to get funded, or they put the hat in the ring. They say, fund me for this reason, and they can communicate through this website, right? Like all of that, there's all kinds of things that are required probably to do this. So that's the thing, so, and I have to think through all of that, and get that done by writing code. And so I will write it in Prolog, and I'll describe it, and maybe I'll create test cases in Prolog and also describe it. Now, maybe I'll finish the software in Prolog, or maybe once it's working in Prolog, I'll write a Prolog program that takes the Prolog program, and turns it into another language, like maybe SQL, and have it run as a database application, right? Now, I don't know yet, but the first step is just to have it done in Prolog. Just basically, and then, try to run that and see if it doesn't run, and then maybe to scale it, it needs to be put on a SQL database. Like it needs to be converted to a database application, and maybe that conversion will be automatic, and maybe I'll talk about that on the podcast as well. So yeah, that's my first podcast. I don't know how many minutes it is, but let's see where that goes.